Så välkomna till Effektsökarnas videoblogg. Jag har en stor äran idag att ha med mig professor Gordon Hughes från School of Economics vid universitetet i Edinburgh. Den här intervjun kommer naturligtvis att göras på engelska. Jag hoppas att det inte ska vara några problem för er. Professor Hughes, very much welcome to this video blog. As you know, we are an organization here in Sweden trying to bring some sense into the energy debate and try to understand what the reasons are for the high energy costs or electricity costs that we are facing. And then, of course, in particular in Sweden, we have the problem with, possible lack of power, possible lack of electrical energy, and so on and so forth, based on the recent decommissioning of nuclear plants ahead of time, and so on and so forth. And of course, the rapid onset of wind power in Sweden. I think we have now something like 4,500 wind power plants up here, and of course the government is very enthusiastic about this, and they want to build more. And of course they also want to build more offshore capacity, which may be right, may be wrong. I don't know. But you seem to be a person who've studied this for a long time. What do you think? What is the status of wind power in Europe? Does it keep its promises, or what's your view on this?
My view is that wind power is very largely the product of subsidies. It would not exist, certainly not at the scale that it currently is in Europe, without very generous subsidies. I can speak particularly about the United Kingdom and Denmark because I studied those in detail, but I've also followed the pattern in a number of other European countries. And in all cases, you can trace the rapid development of wind power to the generosity of the subsidies that are provided. That works if your goal is to have a larger share of renewables in the electricity mix. It becomes dangerous when that share of renewables goes above a level at which it begins to jeopardize the security and the resilience of the grid.
When does that happen? How much wind power can you allow in a grid?
It varies with the other elements in the system. Wind power is an excellent partner to reservoir hydro, where you can control when you release the hydro to match the lulls in the wind or the peaks in demand. On the other hand, it matches very badly with nuclear power because nuclear needs to operate in a stable mode, unless you're France, and the consequence is that it's difficult to find the backup capacity to large amounts of wind. So my own view varies according to the place. I think Germany has got to the stage where the amount of renewables, both solar and wind, is seriously destabilizing the market. I think the same is true in Britain. Denmark is a different story because Denmark is able to export power in large quantities in both directions, both to Scandinavia and to Germany, and therefore, it's just a transition route between the two. So circumstances matter enormously in that respect. But I think in the case of Sweden, you're probably getting to the stage where it's going to be more and more difficult to control the stability of the grid, especially as more and more wind power is built.
In Sweden, there is, of course, a substantial amount of hydropower, but it only covers about half of the maximum, the peak power output, which typically happens in the winter when it's a really cold day in Scandinavia. And so the question is, can wind power then cover the sort of the second half of what is required? And of course, that is very difficult without some extra additional storage capacity or some backup.
I doubt it. I mean, Sweden is not Norway. It's not Brazil. It's not really heavily dependent on hydropower in the way such countries are. And I think more or less the guide that you have to think about is that if you think in terms of firm power, that's reliable power, dispatchable when you require it, wind capacity has almost no firm component. People vary. I personally think the firm component of wind power is about 5% of capacity in UK circumstances. Other people believe that it might be as high as 15%, but both of those numbers mean that you need backup capacity more or less equal to the amount of wind capacity that you have.
Exactly.
So in effect, your hydro is fully committed as backup to the wind power, and you need the other 50% to be covered in some other way.
Yes, and I've noticed that with Denmark. I think Denmark is a good example of that, because you have, I mean, you have a lot of wind power, of course, in Denmark, which works when weather allows it, so to say, and then you have a second system, which is thermal power plants, which can sort of cover the rest whenever that is required. So in some way, I guess Denmark could be said to have two parallel power production systems in place. And I just wonder, that must be extremely expensive to maintain.
Indeed it is. And of course, as I've alluded to, Denmark is favorably placed because it's got strong links in terms of export and import, both with Norway and with Sweden, so that it can draw on the hydro capacity that's available there.
Yeah.
It also acts as the route by which excess wind generation and solar generation in Germany, in effect, travels up to Scandinavia.
Yeah.
So it's a very peculiar system, but it's also a very expensive system because, as you say, they have to maintain an almost complete backup of thermal generation combined with CHP plants to operate, to guarantee stability within the country as a whole.
Yeah. One thing that I've noticed when I read your work, Gordon, I should say that to the viewers maybe, that I've read two reports from Edinburgh, from the School of Economics there, which you've authored. One is concerning wind power in the UK, and one is concerning wind power in Denmark. And I remember when I read just a summary of the wind power in Denmark, it knocked me sideways, as they would say. I thought that was absolutely incredible. Those are very, very poignant conclusions. Would you like to just talk a little bit about the most important ones there? And I'm thinking about, for instance, things that I didn't know or didn't quite know. Maybe I suspected them at the time, but that was that the power output of a wind power plant, of a wind turbine, is reduced heavily in the course of its lifetime.
Yes, I should give a little bit of the background. One of the reasons why I've spent a considerable amount of time looking at Denmark is that it's unusually open in terms of reporting the performance by wind turbine. It was by individual wind turbines or by wind farm in the case of the offshore farms. And it's possible to track back, roughly speaking, 20 years to look at how the performance changes with age. And there are a number of things which are interesting because I've done the same exercise in the United Kingdom, and there are differences between the United Kingdom and Denmark. Denmark, of course, is a pioneer in wind power. It developed it in the 1980s. It has Vestas as a very big producer of wind turbines. And one of the things that is particularly interesting is that the original generation of large wind turbines, not large by current standards, but by then standards, up to about 0.5 megawatt capacity, were really quite reliable. They didn't break down very often. They operated at a relatively constant level of performance, and essentially they lasted a lifetime, which was around 20 years or just a little longer. But the next generation, which followed that, when you moved from up to 0.5 megawatt to between 1 and 2 megawatts in particular, proved much less reliable. They broke down much more often, and as you say, their performance declines over time as they get older and older. Now, my personal view has been that in order to scale up and to change the costs and the other factors, the turbines that were produced in this larger category were not as over-engineered. They were not made to be as reliable as the ones that had been built before them. And there is a second pattern that goes with that, which is every new generation of wind turbine has proved less reliable than its predecessor, and has also gone through a pattern of, as it were, enhanced failures in their early years of life. And you can see the same pattern, particularly in offshore wind, where there were really major outages in the early offshore wind plants built in Denmark. Some of those outages were actually caused by transmission failures rather than by the turbines failing. But even the turbines are prone to fail at a much greater rate than their onshore comparators. Mm-hmm. And so we have this pattern where wind power has tried, the industry has tried to scale up to build bigger turbines with more output, mobilizing more of the available wind resources. But in doing so, they've in effect opted for lower reliability and shorter lifespans. And the consequence of that is that I don't expect current generation of wind plants to last as long as those very early ones that I was referring to that were built in the 1980s and the 1990s.
If I may speculate just a little bit, I would say that probably has to do with the competition in the area now. A producer like Vestas, they were very dominant in the 90s, and they could do solid engineering work. But now, of course, they have competitors. They need to be on the market with a new model very quickly, and maybe they cut corners. And they also need to cut costs. So, as you say, they may not be as properly engineered as they used to be. But I don't know. Maybe that is the case.
But I'd add something else. They're getting more into the frontiers of the technology. Mm-hmm. They're building turbines which, the original ones were typically 40, 50 meter diameter blades. Yeah. They were possibly 50 meters to the hub height. Nowadays, they're talking about offshore ones, which are 200 meters to the hub height with 250, 260 meter blades. These stresses are completely different. Yes. In these kind of things. Yes. And I think the other thing about Vestas, and I think this is another revealing insight into the industry, it's been remarkably unprofitable. There is a whole history of bankruptcies in turbine manufacturing. There are far fewer manufacturers today than there were 20 years ago, largely because of takeovers or by bankruptcies and by failures. And I think actually the competition is, as you say, severe, but it's resulted in a concentration in the industry which actually means that they're not under quite as much pressure to do the best in engineering terms, because there's very little choice. If you want to build an offshore wind farm in Britain, there are only 3 people you can go to who are capable of building the right kind of turbines and delivering them within a 5-year period.
How about wind power? Does it carry its own costs? That's something that has interested me for a long time. I'm thinking about decommissioning and return to green and that sort of thing. My background is in nuclear to some extent, and most nuclear plants that I know of have a requirement to return the site to green field once it's been decommissioned. And I wonder, is that the same with wind power in the UK and Denmark and elsewhere?
It varies from country to country. In the UK, there is a nominal obligation to remove everything after the expiry of the consent, the planning consent to build the turbine. And all of the companies maintain decommissioning funds to remove the equipment at the end of their life. The reality, however, is a little different. The reality is that there have been very, very few wind farms that have actually been taken out of operation. The turbines are taken down, but the wind farms tend to be, as they say, repowered. What happens is that the original turbines are replaced by bigger ones. The turbines have to be taken down because essentially the space between them has to change as you build bigger ones, so that you need to take away the old masts and the blades and everything like that, but you can leave much of the other civil works in place in that kind of respect. And nobody does a full decommission. Nobody actually digs up all the concrete, because remember that turbines have to have enormous underground mass in order to keep them stable. So there's huge amounts of concrete that is poured in order to ensure that they don't fall over when they're generating.
Of course, yes.
And that's left in place.
In Sweden, it seems to be that there is no such requirement. Wind operators, they are allowed to leave the concrete foundations where they are. They are required, I think, to sort of shave off maybe a couple of inches or so, and then shovel a bit of dirt on top of it, and that's it. And when I've asked wind power people about this, and also some environmental organizations, they say, oh, that's okay, because concrete is a natural material. Which I found it hilarious. I mean, because the sheer amount of concrete required for a fleet of 4,500 or even more now wind turbine plants, or whatever you call them, it's phenomenal. It's absolutely outrageous, and it's also, I mean, just imagine getting rid of them, and at some point in time, it's going to be phenomenally expensive, I think.
The issue of decommissioning was never properly addressed at the beginning of the industry. And there is a very sad case of that in the United States. One of the very early areas where the industry was developed was in California.
Yes.
Back of the coast, in the windy areas that benefit from the wind that comes off from the shore inland and then hits the higher ground in the area back of the coast. That was developed in the early 1980s under very favorable subsidy arrangements and the desire of California to promote renewable energy. but they never properly required what was going to happen when they reached the end of their life. And so there was a vast number of relatively small, but very, very large number, tens of thousands of turbines that were abandoned in the area and had eventually, the whole thing had to be cleared up by public money, which was essentially collected. I mean, it was a levy was actually put on the industry to raise the money and to remove all of these dead turbines, which were just standing there. I mean, not even the concrete removed, not just the concrete not being removed, but the masts, the blades and everything were just abandoned. And there was an almost deliberate strategy of companies going bankrupt and abandoning the liabilities in that kind of way.
Yes.
We do need to think more carefully about that.
PPAs seem to be a buzzword in the industry these days. Could you just explain very briefly what a PPA is, how it works, and how it sort of funds wind power?
Right. Let's explain the acronym first. PPA stands for Power Purchase Agreement. Now, power purchase agreements are standard in the electricity sector, but they're particularly standard in sectors which separate generation from transmission and from distribution. In the old world, we had vertically integrated utilities, and Vattenfall in Sweden was such a vertically integrated utility. But about 40 years ago, we, that's economists, of which I'm one, thought that you would get better efficiency by encouraging utilities to specialize, some of them to be generators, other of them to be distributors and the like. And the generators needed to be able to sell their power in a reliable way. And a PPA is the agreement that is made between a generator and somebody who wants to buy power, and they buy the power from the generator. They, in effect, have it transmitted over the grid and pay the grid for it, and then they distribute it either to a factory or to a bunch of consumers or whatever it may be. So PPAs are not new. However, in order to fund the building of large, expensive wind farms, you need some stability of revenue. So a PPA is a way of guaranteeing a stable flow of revenue that is typically separate from the market price. So the market price fluctuates a great deal by hour, by month, by season, and so forth. Whereas typically a PPA will guarantee an average price over a period of time, though it may be adjusted slowly to reflect the market price. And there is particularly an incentive for corporations that want to give the appearance of being more green than perhaps they are, to enter into power purchase agreements with wind farms by which they say, we will buy all of your power, we will buy it at a price above the market price, but not necessarily by a large amount. And in return, we will boast that we are running our operations entirely on green power. Now, the reality is that electrons don't know where they come from, and so the power itself isn't green in any real sense. All that has happened is that they have facilitated either the operation of or the building and operation of a wind power plant by guaranteeing the developer an above market price for the power that they produce. So that, I hope, is a summary of what PPAs are about.
Yes, but also the consequences let's just take an example. The Münchner Stadtwerke, the power distributor in the city of Munich in Germany, they have built wind power plants, wind turbines in Sweden. So what is that all about? I mean, are they really expecting to direct all those electrons right all the way down to Munich from northern Sweden? That's quite a distance, I tell you. And or is this just some kind of greenwashing? I'm puzzled by this. Because also when I look at the statistics in Sweden, there are plenty of statistics I can tell you that you can dive into if you like from in this country. I can see that there's a amazing correlation between wind, so I should say overall wind power output and exports, power exports from Sweden. So whenever there is wind, the wind power starts generating, but almost all of it is exported, which makes me wonder if this country is becoming is being colonized by the rich and mighty of this world, or do they just want the space up here to build more wind turbines? I mean, Germany is already chock-a-block, full of them as it is. They can't really find much more space to build wind power in Germany. So what is the deal? What is going on here?
To be harsh, it is just greenwashing. The situation is that almost certainly in Germany, and I don't know all of the details, but it's certainly the case in the United Kingdom, you are allowed to claim that you are supplying people with renewable energy if you can point to what we call renewable energy certificates. In other words, you can point to having the right to take power from a renewable energy source, whether that be solar plants or whether it be wind farms or whether it be biomass, if that's allowed. And in most of Europe, because it's a single market, it doesn't matter whether that power is produced in Sweden or whether it's produced in the south of Italy or indeed in München. They're just certificates which say you've purchased or you've acquired the right to this amount of renewable energy. Mm-hmm. Now, all power is traded continuously. It's not what most people think. When they think, in Britain, when you're told that all of the power from this and that supplier comes from green sources, they think, as it were, that supplier actually owns literally the source of the power and is delivering it to them when they switch on the kettle. But that isn't what goes on at all. It's just all mixed up in the grid in some sense. And it's nothing more than putting a label on the fact that you have bought this amount of power. And you may well have simultaneously produced lots of power using gas and sold the right to that as well. Who knows? It's all smoke and mirrors, in a very complicated way that mostly depends on telling the public things which bear no relationship to the way that electricity systems actually work.
Mm-hmm. No. Yeah, so it's all a bit of a theater, isn't it? Yeah.
Yes.
All right. I think one final question for you today, Gordon, would be what happened? What caused the onset of very high electricity prices in Europe a couple of months ago? This was even before the Ukrainian war started. So something happened in, shall we say, in fourth quarter of 2021. What happened? Why?
Right, I'm going to have to take a step back because this involves more than one element of the economics of energy systems. The first thing to bear in mind is that natural gas is a fuel whose price has historically been quite volatile. It's been prone to go up and down according to demand. And the reason for that is that the availability of natural gas only changes slowly because it's largely controlled by pipelines or by transport more generally, not just pipelines, but LNG, ships and the like. So essentially, if demand goes up a lot and supply stays constant, the price goes up. And that has happened in the gas market on and off for the last 20 years, ever since gas became a major fuel for electricity as well as for heating and for other uses. What happened then in 2021 was that gas production was cut back during the pandemic from 2020 on because demand fell and prices fell very dramatically. And so as a result, producers, particularly in the United States, stopped producing because they saw no point in producing at very low prices. Then, when the world started to recover economically from the recession that accompanied the pandemic, the demand for gas started to pick up very quickly from actually earlier in 2020, but it fed through into prices of gas naturally over the course of the summer and then the autumn of 2021. So that's the gas side of the story. The electricity side of the story is that we have electricity systems which use gas as the marginal fuel. What that means is that when demand goes up and there isn't much wind or there isn't much sunlight, gas power plants are switched on, and those gas plants have to make money to be willing to operate. So the price of electricity has to go up to pay for the gas that they need to consume. So throughout Europe, we have a system which at the margin, that is to say, during periods particularly of high demand, and winter is one of those, is driven by the price of gas-fired generation. So now you have two things happening. The price of gas was going up by the general demand in the world economy. Secondly, we had a heavy demand for gas for power generation because actually last autumn was particularly low wind in large parts of Europe. So wind generation was relatively low. And since it was autumn and winter, solar generation was relatively low. And so the demand for gas-fired generation shot up. So this combination of circumstances was what drove the price through the roof. Now, what happened in 2021, the fourth quarter, as you referred to, was unusual, very unusual. It was not literally unknown that prices would go up like that. They'd done that 3 years earlier. So it's not an unusual phenomenon to happen. The scale of it was unusual because the gas price was driven up so much by demand from Asia. So what you had was the gas price going up, low wind conditions, large demand for gas for generation, feeding through to very high electricity prices. And of course, now with all of the restrictions on Russia following the invasion of Ukraine and so forth, the gas market is going to be mad for the next 12 months or so. And prices are likely to remain not necessarily at their peak, but pretty high for many months to come. And and in Britain, but also in Europe, there's a lot of running around. In Britain, we say like headless chickens. That is to say, people not knowing what to do in a panic. And there are all kinds of suggested solutions, some of which make utterly no sense. You know, one of them, for example, is that we should have yet more solar plants and yet more wind farms and the like, because that would reduce our reliance on gas. They completely forget the fact that we weren't short of wind capacity, or we weren't short of solar capacity last winter. It just wasn't producing because there wasn't enough wind and there wasn't enough sunlight to do so. Yeah. And relying even more heavily on those would merely make the situation worse. But the trouble is that it's extremely hard to adjust your generation mix quickly. In Germany, they're talking about delaying the decommissioning of nuclear plants, of running coal plants. In Britain, we may not be able to do either of those. We do have some recently decommissioned nuclear plants, but the coal plants have mostly been blown up. You know, they collapse them by putting explosives under the all of the buildings and so forth. Really? So we have very little flexibility in the short run. And the only thing that we can really do in the short run is either change the hours that we run the capacity that we have, which is not much good because that's gas and that's going to be expensive, or, and this is one of the things that needs to be thought seriously about, is to build as quickly as we can ultra-efficient gas plants. So while they're more expensive, they run at much higher levels of thermal efficiency, and thus they use less gas and can produce less expensively given the price of gas.
Yeah. I would like to throw in another reason for the price hike, if I may. Germany has decommissioned basically all of its nuclear reactors. I believe at its peak, Germany had 22 reactors or something like that, and now there are 3 left. And in my view, that is a very significant power generating capacity. And if they hadn't done that, and if Sweden hadn't reduced its power, its nuclear power by almost 40% or something like that, the game plan would have been different, because then the electricity generation would have been less dependent on gas. So you could possibly have isolated the high gas prices to gas consumers, and now it has sort of, you know, infected the electricity market as well. And in Sweden, which is a country which uses very little natural gas, this is a tragedy. I think it's really, really sad, because it changes so much in terms of what sort of industries will be possible in the future, and what, you know, people's standard of living and all that. You know the eat or heat discussion that you probably have had in the UK.
Yes, I mean, you're certainly correct about that. If you take stable, reliable supplies of electricity off the market, you put much more weight on the alternatives. And of course, the thought in Germany was that wind and solar would provide those alternatives, but they don't, or at least they do, but only some of the time. Yes. And I said earlier in this discussion that the German market has reached a point where the prices are profoundly unstable, because essentially you're moving to a situation where either you have excess generation because there's a lot of wind and a lot of sun, and the prices go through the floor, or alternatively, there's very little generation and the prices go very high. What had happened in Germany over the last few months of last year was essentially that it was oscillating. The prices were oscillating between being very low and being very high.
Yes.
It was just that it shifted to being very high for more of the time because there was less reliable supplies available from nuclear and from other sources. And they were, of course, running coal. I mean, this is always the irony about the German one. What they did was that they retired nuclear plants and then they built more coal-fired plants.
Yes.
And they ran the coal-fired plants for longer because they needed to replace the baseload capacity within the system. I mean, the problem about all of this is that there are two threads to environmental concerns. One thread is about carbon dioxide and global warming and the like, and is understandable. You see what the logic is behind that. And that leads to the desire to have low carbon generation. But the other thread is a long-standing, historic, almost hatred of nuclear power among traditional green groups. You have that all over the world in that they just despise nuclear electricity. And that runs directly counter to having low carbon generation and leads to this kind of incoherent policy making, which puts much too much weight on a source of generation, that's wind and solar, that it's not capable ever of bearing.
One would have expected the Greens to step up and accept, for instance, nuclear then as the lesser of two evils.
There are indeed some who do.
Yes, I know.
They're very few.
Yes, yes. Yeah. No. Anyway, I mean that I think that would qualify for a second interview with you, Gordon, to hammer out all the politics of energy. So, but I think we could end this this interview here. I thank you very much for participating. It's been a pleasure, a great honor for me to have you on board here. Thank you very much.
I've enjoyed it, and please, when you distribute this interview, pass on a link to the papers that you said you'd read, so that anyone who is interested can follow up, because I don't want people to take me at my own word, but read what I've written.
Thank you, Gordon. We will do that, definitely.
Fine. It's been a pleasure. Thank you.